Hello, everyone. Thank you very much for joining today. We hope that you can see us and hear us well. If that's not the case, just let us know. Today's session's topic is Flowmon Packet Investigator. We will be demonstrating its features with our product manager, Martin Skoda. Hi, Martin.
Hi, everyone.
And hopefully you'll enjoy it. So again, good morning, good afternoon, good evening to everyone. We will make sure to record the session and send you the recording after it's finished. And the session is interactive, so please do send your questions using the question tab of our GoToWebinar tool. Without further ado, let's start with the presentation. And so Flowmon Packet Investigator is a new product. However, for those of you who are familiar with Flowmon, you know that Flowmon Traffic Recorder has been with us for a few years now. And Packet Investigator is actually evolution of this product, which is changing the way we use and interact with the tool. Why did we do it in the first place? Actually, the problem is that with heterogeneous environments of our customers, we see that they are using multiple tools that very often have some sort of overlapping functionality. To be able to monitor and track and have visibility into all kinds of environments, all kinds of tools, and cover broad spectrum of use cases, it's not really easy to do it with one single tool. We definitely don't want to claim that Flowmon can replace them all and sort of one tool rules them all. There's definitely the need of mixing your tool set to fit your needs, but there's quite a lot that we can and that we have already incorporated into Flowmon to get you covered in most of the network troubleshooting cases. Here are some statistics. Absolute majority of mean time to resolve or resolution, depending on how you use it, is spent on actually making sure and figuring out that the problem is there. It usually starts with some users calling and saying there is some problem. It takes quite a long time to respond. And this is all wasted time. And during this time, the impact actually raises. And the second number isn't really surprising to me, and as we discussed it before the call, neither is this to Martin. About 1/3 of network management time is spent on reactive troubleshooting. And we hear this from our clients all the time, that instead of focusing on projects and working on their infrastructure updates, etc., they go to the office in the morning and they spend their time just figuring out and trying to manage all the red flags and alerts. And this is really wasteful. There are multiple approaches on how to solve this problem, and Flowmon covers two main parts. They are often being compared. Flow versus Packet. Flow representing a network telemetry data, usually IP headers with some level of visibility into application layer, but definitely not as deep as Packet that covers entire raw communication, has a lot of advantages. Flow is scalable, so even massive networks and with the explosion of bandwidth that's used by users and applications, Flow can scale to these speeds. It's efficient for encrypted traffic, which means that if used wisely enough, information that you can pick up from even encrypted traffic usually suffices for troubleshooting. You can easily do your capacity planning, QoS monitoring, and in general traffic structure monitoring with flow data. But on the other hand, it often lacks in detail. It doesn't provide the level necessary to do troubleshooting of every type and kind of root cause. And sometimes you need to drill deeper, all the way into the level of packet. And if you use NetFlow data from routers or switches, it can often be sampled. SFlow is one of the most commonly used formats, and S means sampling. So we're using some granularity and we're using some detail. But on the other hand, while Packet does provide the level of detail that we need for any time, it's not really wise to use packets at all times, because it gives us a lot of noise, and that means it takes quite a long time to troubleshoot with Packet. Also, it's not really effective for security monitoring because of the amount of data. And also, when the traffic is encrypted, which in majority of internet traffic worldwide today is the case, we don't have any benefit by recording the data, recording the application layer, because that's the encrypted part which we cannot see into. But we still have to record all this traffic, which means we need a lot of resources to do that, and it could be quite costly. So what we believe is actually that combination of these techniques can be the most fruitful one, and it actually delivers quite a few benefits. Specifically with Flowmon Packet Investigator, with its inbuilt analytics, we can automate the troubleshooting, and we will show you exactly that in a few moments. The solution provides expert experience that we will demonstrate. So that means people who maybe don't have that much skill, haven't been in networking for such a long time, or even people who don't have that much time but have the skills can benefit from. Combination of these two approaches is helping to reduce downtimes, because having the high-level visibility, being able to detect anomaly using flow data, being able to do drill downs and do full analytics, but also having the detail all the way to the packet for forensics means that all the data is at your disposal and all the data is ready for you to use in your troubleshooting. By combining the tools, we're reducing the number of tools needed in total, which is always handy because it reduces costs, and it also reduces the number of applications you need to deploy and have support for, and that you need to learn to use. And all in all, it provides hard evidence anytime you need. So in case if you're struggling to convince your supplier and provide hard data, hard evidence, it is there for you at any time, and you're not actually losing any detail, because as I mentioned, Flow doesn't actually carry the full information. It carries just some portion, but in combination with Packet, you have everything you need anytime you need for your evidence. So how does it work? We use Sensor, our pros. Most of you are familiar with them. They are connected to SPAN or TAP, even in virtual environments where we support BTAPs of public cloud providers. And these probes are capable of capturing traffic all the way to 100G. 100G, obviously, for physical networks, it's not that easy to do in virtual. That means if you have 100G lines, we're able to filter the respective traffic within that speed and record what you need. And you can also upload your own PCAP. We'll show that in a second. Then comes the step of analysis. We support many protocols. I believe there's around 14 at the moment.
Yes,
right?
exactly.
And for these 14 most commonly used protocols in enterprises, we're able to do automated analysis. And then we report the data on the dashboard and showing you sort of traffic lights with option to drill down. What are the typical use cases? Here's the summary, the most common one. It starts with network connectivity issues. So specifically the case where there is some error in TCP stack, problems with handshake, and problems with losing packets on the way. misconfiguration of services. Very often it could be DNS, it could be DHCP, and elementary protocols and services that are critical to functioning of the networking. The client-server encryption incompatibility is here very much because we will show this use case on the live data today. But definitely there is a much wider range of application protocol issues that we're able to automatically find a root cause for. So let's start with the gathering, with the recording part. Flowmon Packet Investigator can either be instructed by Flowmon ADS, Anomaly Detection System, which is a system that uses machine learning to detect anomalies in the network and provide early response and warning. And upon an event detected by Flowmon ADS, Flowmon Packet Investigator will create a filter to capture the respective traffic surrounding the detected event, and it will provide you with the recording. But you can as well trigger the recording manually. It's fully manual process, goes in a few steps. We'll see later on. You can schedule your triggers, but you can also upload PCAP that you've recorded some other time or using other system. It doesn't really matter. And we will read it and process it using our decision tree analysis, and then we'll present the data on the dashboard. The analysis itself actually has three key sort of features. We, in the first place, are looking for privacy. So we've learned how those 14 most common protocols should be working, how they should be used, and we have this knowledge that we have inbuilt into the system that looks for anomalies and deviations from using these protocols. We've created a database of built-in experience that then takes the error codes that we find, and not only error codes, but really just odd and awkward and unexpected events that we see, and translate them into human readable explanations. So the system will actually show you a sentence that describes what happened, and so that anyone can understand. And then we show you the traffic lights that tell you instantly, here's an alert, here's some error, here's some fatal error that caused the problem. It is the root cause, and this is where you should be focusing your attention. And last but not least, the system shows you suggestions on remedial actions. I mentioned that we've built in expertise in it. We tend to say that our pre-sales engineers and what they usually do using Wireshark or other tools has been now put into the system. And we by no means are trying to say that we are better than Wireshark, because we're not better. We're not the same type and kind of tool. We're used for different use cases. So while Flowmon Packet Investigator is mature by providing automated analysis and inbuilt expertise, it would be like comparing apples and pears. And having said that, we have a table. It's not comparison table, it's a differentiation table that compares the two. Giving me a hard time to find other words to say compare. And we did the differentiation in 4 primary steps. Required skill set for Wireshark. Most of you know the tool. You need some skills, you need some deep level of knowledge of what you're looking at to be able to troubleshoot with it. And so it's often used by L3, L2 engineers, senior and administrators, or architects. Whereas Flowmon Packet Investigator descriptions and human readable explanations can be used by operators and more junior roles. The primary use case, which is the main differentiation, is that while Wireshark is used for manual analysis, forensic analysis in terms of post-compromise, post-incident deep analytics, whereas Flowmon is really off-the-shelf, out-of-the-box analytics for fast problem solving, for root cause analysis of the majority of the most common issues. Third category is packet capture. Wireshark isn't really scalable, isn't really complex, right? Because it means you have your Wireshark installed on your laptop, you have to go to the data center and physically plug in and start the capturing. Also, you're limited with the hardware resources of your laptop. Whereas with Flowmon, it's really a distributed architecture. You can trigger your recordings remotely, just using the probes deployed all around your network and instructing them from central management console, having the capabilities to record up to 100G speeds, and planning, scheduling, and automating the triggering. And speaking of automation, you can obviously build some scripts in Wireshark to help you with automation of certain repetitive activities. But Flowmon Packet Investigator off the shelf can give you the automated trigger capture, and using REST API, you can integrate it with your tools and use it completely separately outside of our own UI. So let's get to the demo, and I will now give you the presentation, Martin. And in the meantime, I'll use the opportunity to close the window that we forgot to close. It's all yours, Martin.
All right. So today I will show you a simple use case. Let's start with the story. So you are a network administrator and user complains about the issues with sending emails. So first of all, as a network administrator, I will check if everything is okay from the network perspective. So I logged into the Flowmon, into monitoring center, where I can see the traffic charts, and I have set my profiles, and I can drill down to the flow level. So here I have the analysis page, where I can specify what data I want to analyze. So I know that the user IP is following, and I know where the issues happened. So I just selected the interval on the graph, and now using the filter, I will get some top statistics. And I will actually see here that this host is communicating. So no communication is blocked. It's communicating with this SMTP server. So I will drill down to see the flows. So first of all, there is communication. That's a good sign. Then I can see that there are some other information from the flow. So as I can see, the communication is set up correctly. I don't see any reset flags. So this TCP communication was fine. So my conclusion is, from the network perspective, everything is okay. There is a communication. Client communicates with the server. They start the communication via TCP correctly. So there's no issue. No issue. So the next step I'll do is record the traffic so I can analyze it. I will deep dive into the packets and try to find some issue there. So now you can see the packet investigator. I can create a recording, or I can upload a pickup, but I will record traffic. So let's name the recording. There's option to describe what's going on, to have some context. And there's a filtering criteria. So I will enter the rule to capture just the traffic for that specific host, because I don't want to capture all the traffic and increase the noise. So I will do just this. Okay. This needs to be unique. As you can see, I prepared. Okay, so now I'm recording the traffic, and I will replay the PCAP with the communication. Okay. So let's check the results. The traffic is ongoing. I replay the PCAP with the communication, so I can now stop the. I can now stop the. Oh, sorry. I need to do it one more time because this page with the recording was not updated, so there is a wrong interval. So let's do it again.
At least it shows that it's live and real.
So I will replay the PCAP again. Right. Now we can see that there's the recording. It's active. I will stop it because the communication is already replayed. And what are my options now? So first of all, I can download the captured PCAP and analyze it in the Wireshark. And if I do it, open the PCAP in the Wireshark, I can see the details of the communication. I can see the individual packets. So I can see that there is a TCP communication which started, that there was a communication that client server welcomed client. There's a hello. The server sent the options to the client. Then the client choose to start with the encryption. So we changed to the SSL protocol. Client and server helped each other. Server sent a certificate. They were sending some information to exchange the keys, and then it failed on this packet, or this is the record. What went bad? So we can see some fatal message, which is described as bad record neck. So most of you probably know what happened, and I do too, but this requires, as you can see, this analysis requires some manual labor. It requires time. Of course, you can filter the communication, see the packets, but you need to go through them, find the error. And once you see what's wrong, you also need to come up with some solution how to deal with it. Or there is a second way how to do it, and that's the automated analysis in the Packet Investigator. So I can just start the analysis manually if it does not start automatically after the recording. That's the option in the previous page. Then I can select what PCAPs I want to analyze and which protocols I'm interested to. So the users reported issues with emails, so I will select SMTP, and I will start the analysis. Okay, the analysis is done, but I will wait until the window refreshes. And now I can see the traffic lights, as Artur mentioned, so I can see that there are some issues. I want to investigate further, so I open the detail and immediately see in the human readable form how the communication went and what happened. So this is the events tree, which describes how the communications which are captured, how they happened, what was detected. So here we can see that we detected some SMTP communication, that server welcomed the client. We saw that in the packets also. Then there is a warning that no authentication was detected. This is something which we didn't see in the packets. We also would come with this because we didn't see the comment or the packets regarding the authentication, but some might have missed it. So this is also something which is there extra. And then we see how it went further. So the client and the server wanted to start the encryption. So there was SSL handshake detected, and then it went with this error. So no email were sent, and the communication stopped here. So looking at this event, we can see that not only that you have a packet information you are able to get in the Wireshark, you have also the description of the error. And if you look next to this icon, you can also see some explanation what happened and the suggestions. So the mentioned expert experience. So here we can see that the peers failed to negotiate the shared key material, and therefore the network admin is suggested to try a different cipher suite or to switch to another protocol version, different version of the SSL. So this is much more readable information for the users. It's much more readable for, as mentioned, some operators, junior network engineers, layer 1 support. It also have benefits for experienced people because it saves you the time you need to do, saves you the work you need to do in the Wireshark. So this is much quicker, and on top of that, it will also tell you or suggest you how to do the remedial actions, what to do with that situation. So that's everything from the demonstration, and I'm passing more back to Artur.
Thank you very much, Martin. I will switch the sharing back to myself. And thank you very much again for again, it just shows that we're running live and on real data, so not to worry about the hiccup. And I managed to answer some questions, but one that I could not was that you were using the replay tool, and the question was whether the person who asked can use the replay tool because it says it's Flowmon.
Yeah, this is in our lab, so I'm not sure if it is in the Flowmon appliances available for Flowmon user, which are typically used by our customers. So I don't think it is available, but I can check it with guys.
We'll come back to you after the session. All right. So great news is that Flowmon Packet Investigator is now available with 50% discount. That applies to both Flowmon customers that don't have Traffic Recorder yet, and also to those who have Traffic Recorder, but also to non-Flowmon customers. So how this works: if you are a Traffic Recorder customer, get in touch with your salesperson, or they will get in touch with you, and you will be offered to upgrade Flowmon Traffic Recorder to Packet Investigator, or keep your Traffic Recorder as it is today. The upgrade will be actually a price of the difference between your current Traffic Recorder price and the new Packet Investigator license. And the discount will be applied to this. For those who don't have Packet Investigator or Traffic Recorder, you can use a free 3-month trial, starting with the stable release of the product. And after this period, you can choose to purchase it with 50% discount, and this offer is valid until the end of November. I mentioned with the release of the product, we are looking to release it very soon, hopefully next week, but definitely at the beginning of June. We will keep you posted, and we'll definitely release the news publicly with blogs, social media, etc. So stay tuned, you will be informed. But you're free to go ahead and try beta already. There's more reading available today. Go to our blog to read more about Flowmon Packet Investigator. There's also a data sheet available in the resource library. And I would also like to mention Flowmon Network Monitoring ebooks. So if you search for ebooks, you know what? We'll actually send you a link in the follow-up email. Flowmon Network Monitoring ebooks is a set of 3 articles by Pavel Minatic, our CTO, who explains the differences and the benefits of different approaches to network monitoring, from SNMP to Flow to Packet and their combination. We have some more questions, so I'll try to open them up very quickly as we speak. But what I also wanted to mention is that, and I completely just forgot what I wanted to say. So let's see the questions. Can we simply add this new stuff with the collector, or we need to add the probe?
Yeah, so this automatic analysis is a thing in the collector package. Yeah, so you will upgrade the collector package. So the FPI on the collector does the analytics, but you also need to upgrade FTR or FPI on the probes because of the compatibility between the versions.
Yeah, so also the answer is you need to have probes, because simply by collecting NetFlow you can't see into the packet. So you need some sort of probe functionality, and that can be inbuilt into the virtual collector, or it can be standalone physical virtual probe.
Yeah,
you need this functionality.
Well, you can rely on some PCAPs you capture some other way. You don't need the probe. You can capture the PCAP other ways, and then use the upload function in the FPI to analyze those PCAPs. But if you are asking about how to upgrade, or how to upgrade, you need to upgrade both packages on the probes and the collectors.
Great.
To the current version. Yeah.
If the client currently has Traffic Recorder and wants to try out Packet Investigator, and then choose if they want to upgrade, can they get a trial license? Yes, for sure. Ask for trial licenses through the standard process. When the stable is available, we will actually offer the trial on the website. So there'll be a button to click on, and we'll get in touch with you. But if you have access to Flowmon Portal, which partners do, you can request a trial license through the standard free trial request form in there. So there's no problem. So can we add that to the virtual collector? Yes, because virtual collector has inbuilt probe functionality. You can install Packet Investigator on the collector, and you can use all benefits and features of Packet Investigator on your virtual collector. Yes. Okay, thank you very much for all the questions. Thank you very much for your time. Don't forget to go for the free trial, and also tune up for next webinar, which will be held on 10th of June. The topic is early ransomware detection and response. Our guest will be Pavel Minatic, and also Juraj Přibyl, who is a SOC manager for NN Insurance Group, covering multiple countries. And he will be the expert, have the expert insight, helping us to answer some of your questions related to ransomware. We will definitely have a demo. We will demonstrate an attack and how we detect it and how we can respond to it. This is all from us. One last question just came through. Let's read it to make sure that all your questions are answered. Does Packet Investigator help somehow to solve the problem besides identifying it? While it doesn't solve the problem for you, it shows you suggestions on remedial action. So in our case, the detection was there was a problem with encryption handshake, if I mentioned it correctly, and the suggestion was to try different cyber suites. And for every detected incident, there will be suggestion on remedial action. So we won't do it for you, but we will tell you what you should be doing and looking at.
Yes, exactly.
On that, thank you very much for your time today. Looking forward to meet you on the next webinar. Enjoy yourself, stay safe. We kept our distance, so hopefully everything's fine. And cheers.
Bye, and thanks.